Who said science is only for the scientists? This fun experiment is fun for all ages, and it couldn't be more simple. The materials that you would need would be 1. A shallow bowl or container, 2. Water, 3rd is the black pepper, and lastly is the dish soap. Now on to the main experiment. Firstly, you will need to get your bowl and fill it with water. Secondly, sprinkle your black pepper evenly across the surface. Try not to sneeze. The pepper flakes should float, not sink, across the surface of the water. Thirdly, is to pour a little amount of dish soap onto a clean counter. Next is to dip your fingertips onto that dish soap. You will just want a little bit amount of dish soap onto the ends of your fingertips. But wait, before you dip your soapy fingertips onto the pepper water solution, ask yourself first, what do you think will happen if you dip your fingertips onto that pepper water solution? Will something happen? How will the peppers react? Do you have your guess? Okay, now get your soapy fingertips and poke it right in the center of the pepper water mixture. What happened? Was your guess correct? Most of the pepper flakes should have darted to the sides of the bowl. It may have looked like the soap was chasing the pepper flakes away. The first question to ask is, why do the pepper flakes float? Why don't they sink? Or why don't they dissolve in water? Well, number one is pepper is hydrophobic, meaning that water is not attracted to it. The second is the type of the intermolecular forces water has. Water has two types of intermolecular forces. Number one is the hydrogen bonding, and the second is the London dispersion forces. Another is that water is a polar molecule, meaning that there is an uneven distribution of electrons around the molecule, mostly being concentrated around oxygen. The pepper floats on the water due to surface tension. Surface tension on water is high due to the intermolecular forces with 2 hydrogen bonds per molecule of water. When soap is added to the water, it breaks the surface tension of the water, causing the water molecules to pull away from the center, taking the pepper with it. Soap experiences London dispersion forces. Soap also contains a nonpolar end and a polar end. The polar ends of the soap is hydrophilic, meaning that it is attracted to water, and the nonpolar end is hydrophobic, meaning that it is not attracted to water. The polar end of the soap and the water are attracted to each other, while the nonpolar end faces out, and this is how bubbles are formed. This is like if you were in a tug-of-war contest, and the opponent lets go of the rope that you are pulling away from the other side. This is the same concept with the pepper and water experiment.